Hello, and thank you for your time. We at Purple Planet are happy to present to you today the results that you have requested concerning global warming derived from our computer model of the carbon cycle. Before we do so, let us quickly point out some of the limitations of our model. The carbon cycle and global warming are extremely complex systems, ones that we still do not fully understand, nor may ever. Such confounding long-term processes, such as changes in the Earth's orbit and tilt, continental drift, and sporadic severe eruptions, have all contributed to changes in the Earth's climate over the eons. Trying to get a firm grasp on what exactly is causing our planet to warm in such a small window is therefore an extremely difficult task. However, we can logically infer what is causing at least part of the problem by looking back in time to when our planet was a very different place.
This figure maps atmospheric carbon levels with temperature over the last billion years or so. If you look about 2/3 into the Paleozoic era, we see a very large dip in both carbon dioxide and temperature levels. What is going on here? The start of the Carboniferous era was when the first land plants started to establish themselves and quickly dominate the Earth. They pulled massive amounts of carbon dioxide out of the atmosphere in the process. The plant matter compiled and was buried over millions of years and eventually broken down and compressed into the fossil fuels we use today. Therefore, it is reasonable to speculate that burning these fossil fuels is starting to return atmospheric carbon, as well as temperature, back to Carboniferous levels. Therefore, we will assume that focusing on the carbon cycle can answer significant questions concerning global warming.
Here's our simplified model. It not only allows us to observe changes in carbon levels in our different stocks, but also, by way of past data, to predict temperature increase based on levels of atmospheric carbon. There are some important characteristics to observe. First, we can see that there are several more inflows to the atmosphere than outflows. Adding yet another inflow in the form of emissions will clearly create a bottleneck effect in the atmosphere and thus steadily increase carbon levels. Next, we can see the positive feedback loop on the terrestrial side of our model. This means that, theoretically, we could grow more and more plants to sequester more and more carbon. However, we know that there is an obvious planetary limit to this growth. Nonetheless, it is logical to focus our strategies on reducing emissions and increasing carbon sequestration via photosynthesis.
Here's what the carbon levels would look like if we continue to increase fossil fuel emissions at the current rate of 1.5% a year over the next 100 years. As we can see from the graph, allowing this increase to go unabated will cause carbon levels to steadily rise in the atmosphere. This trend will potentially raise temperatures by over 6 degrees Fahrenheit worldwide by 2090. Here's our most successful model at reducing atmospheric carbon. In this trial, we allowed for carbon emissions to continue to grow by 1.5% a year, starting at 6 gigatons a year from 1995 until 2020. At which point they are cut to 1990 emission levels of 5.7 gigatons a year, as the Kyoto Protocol called for. Afforestation is also a supplementary part to this process, though it has little effect on reducing carbon levels on its own. Coupled with emissions, reductions can successfully curb atmospheric carbon buildup. This would require a huge effort on everyone's part to improve technology and reduce consumption to unprecedented levels. Further, despite this, we still see a moderate rise in carbon levels and temperature. Unfortunately, this was the best result we could derive from our model.
So what can we conclude? We are at a tipping point. We need to take drastic action, and we need to do it now. By significantly reducing emissions and implementing afforestation, we can begin to solve the global warming issue. The cost of doing so is small compared to the potential catastrophic effects of global warming, which have been amplified by fossil fuel emissions. Let us come together and solve this issue today.